Come on. Get out of here. All right, so I think at this point I've now spent entirely too much time on these topics. My apologies. I think I already, I'm not sure if I posted that already in your course yet. Let me check. Nope, I haven't. I'll try to post that after class when I get a chance, okay? I haven't got a chance yet. Man, this assessment day has really put a wrinkle in the schedule. Now the other section is like a solid day ahead of you guys. All right, so the next result I need to share with you is called the fundamental theorem of algebra. Yes. That is a good question. Thank you. So, fundamental theorem of algebra. It says the following. Where am I? F of x equal to, let's say, a sub 0, a sub n, x to the n, plus, an minus 1, x to the n minus 1, a2x squared plus a1x. So our usual notation here, a sub 0, where a sub n is not equal to 0. Then f of x equals to 0 has n solutions, possibly repeated. Well, let's say it this way, counting repeats. I'll say it this way, possibly complex. And we're also counting repeats. So the fundamental theorem of algebra, and here we're assuming that the coefficients are real. I mean, that's not necessary for the theorem, but for the context of this class, we're assuming real coefficients, all right? So this means that if you have an nth order polynomial equation, you have at most n solutions. So, for example, if we have x to the fourth minus 1 equal to 0, we can factor that, right? This is x squared minus 1 times x squared plus 1, right? And we can factor that further, actually. That's x minus 1 times x plus 1. And in this part of the course, we're also going to allow the possibility of a complex factorization, all right? So how does that go? Well, x squared plus 1, we can rewrite 1 is minus I squared. So I is the square root of minus 1, so like I squared is minus 1, And so what I have here then, I can rewrite as x squared minus I squared, so that I can factor. Now, so this is x to the fourth minus 1 factored completely over the complex numbers. What is the complete factorization of this over the real numbers. So this is the complete factorization over the real numbers. So what's the deal? I mean, with real numbers, there are some quadratics which we can't break down, right? The quadratics which we can't reduce, the irreducible quadratics, these are the ones that have discriminants b squared minus 4ac, which is negative, all right? To factor those, we need to use complex numbers. We have to use complex factors. And those complex factors correspond to complex zeros for the corresponding equation. So like this example, x to the fourth minus 1, what are the solutions? Equal to 0. What are the solutions actually here? This one gives me what? What's this factor? Gives me which? 1, right? This one gives me minus 1. This one gives me I. Yep. This one gives me minus I. See, if you can do the real case, you can do the complex case. It's just like riding a bike. So that's an example of the fundamental theorem of algebra, the fact that we have a fourth order polynomial and we get 4 solutions, right? In this case, half of them are complex, half of them are real, right? If we just narrow our focus to reals only, we'd only get 2 solutions, right? Because that x squared plus 1 we can't break down. So I think a good thing for you guys to do before we meet again would be helpful to you is if you can find some time to watch the Wednesday lecture from the other section. And what I do in there is I break down like what does the polynomial generally factor as in terms of real and quadratic factors. It's quite it's a lot to write out. It'd be good for you to watch it. And if you do that, I'll give you 10 points, all right? So I'd ask for you to watch that video. I will ask you a simple question from based on the video as a quiz at the start of next class. And if you can answer the question, I'll give you 10 points. So, all right? And I'll try to make the question so that if you've actually watched that video, it's easy to answer the question, okay? I don't know what the question is yet. I'm going to have to watch this stupid thing again, figure out what the question should be. But it'll be something stupid. You know, I'll try to come up with questions that if you have actually watched it, you can answer the questions easily, all right? And I think that's for your benefit. Because then if we do that, I won't need to write out that like theoretical result at the start of that other lecture. And we can focus all of our attention on examples in here next class, okay? That'd be better for us. All right, well, anyway, we can hit the